Alright, y'all, 15.3 homework. Let's get to it. I do apologize for not getting this up sooner. I'll be honest, I just kind of forgot to upload it, and it wasn't until someone actually private messaged me on Edmodo saying, hey, where's the video, that I totally realized I had to do this. So, I apologize, but hey, let's get to the work, and let's get through it. So, the first question on 15.3 asks you to find the inequality that makes this true. In other words, solve it is really what I mean. Like, where are my solutions? So let's look at this inequality. Let's tear it apart and let's figure out what it actually means. So it's still comparing two things. You're comparing the 2x plus 3 to the x minus 1. But in this case, unlike an equation where the two sides have to be perfectly balanced, we're saying there is imbalance here. There is inequality here. In fact, specifically, I want one side to be larger, strictly larger than the other. So if I'm looking at this 2x plus 3, because it's on the side which the sign is opening towards, this has to be the larger of the two numbers. Likewise, because the sign is facing away from the x minus 1, this is going to be the smaller of the two numbers. So what we're really looking for then are x values that keep this red side bigger than the blue side. So let's take a look at that. And we're going to do that by getting these into the table first. So 2x plus 3. X is negative 6. So stick that guy in for x. Substitute, excuse me. Negative 6 times 2 is a negative 12. Add 3 to it, you get a negative 9. Now, I'm not going to stick this 5 in and do the same thing. You totally could, but guys, you did so much work for a semester to establish these kind of rules. Let's use them. The slope here is 2, which means my number will get bigger by 2 each time. So that's plus 2. That's plus 2. That's plus 2. Negative 1, positive 1, and 3. Now, this is predictable because, hey, look, that's the y-intercept, and y-intercept is going to be 3 from the beginning. In fact, we can even make it more to the point. Y-intercept over here is negative 1, so I'll start there. And x's get bigger every time my x's get bigger, or my y's get, every time my x's get bigger, my y's get bigger by my slope. In this case, it's 1, so this would be like 0 right here. Reversing it, of course, so we'll just drop a value. Okay, now let's actually do this analysis. Now, I know we're not looking for equality, but that's an important starting place. Like, where are these two things actually the same value? And if you're looking where I'm looking, they're the same value in negative 4. So what's happening above it, what's happening below it? Well, let's just compare the numbers side by side. Which of the two is actually larger here? And remember, keep in mind, we're trying to figure out where the red is larger than the blue. Is negative 9 bigger than negative 7? The answer is no, it is not. It is smaller. Is negative 7 bigger than negative 6? Heck no, it's smaller. Now, before you're like, hey, Mr. Collins, are you sure you're right about that? I am. Think about this. Which is a lower temperature, negative 9 degrees or negative 7 degrees? Which is a lower bank account value, negative $7 or negative $6? Obviously, these are going to be the warmer temperatures, the bigger dollars. These numbers are bigger. Not what I actually want. Now, when we drop down, though, negative 3 is bigger than negative 4. Negative 1 bigger than negative 3. Obviously, a positive bigger than a negative. So I want the numbers where the reds are bigger. So that's going to be happening right down here. So how do I identify those numbers? Well, these are all numbers at work, and they're below what number is my question, which is a weird way to say that, but hopefully you guys are seeing this. They're all going to be below 4. So the solution I'm looking for are any x's that are smaller than negative 4. Not an easy task. Tables are probably one of the least favorable ways to solve an inequality, but it is possible. All you have to do is, excuse me. All you have to do is know what the inequality means and which side should be bigger, and should be pretty easy to pick out. In a related problem, we have the graph. Now, I already kind of did this graph for you, but I'm going to walk you through the steps so you can see it. Basically, what I did is graph 2x plus 3, which is this line right here that's red. And then I graphed x minus 1, which is this in purple. And the way I did that, in fact, it might be worth it to back up and show you kind of how I did it. I was working these out ahead of time to make sure I had no kind of crazy tricks up my sleeve. So let's back up. So we're still trying to graph, or we're still trying to solve 2x plus 3 larger than x minus 1. And the rules here really haven't changed. Like, we still want the 2x plus 3, which will still be the red side, to be bigger than the x minus 1, which is the blue side. So again, this is going to be the smaller, and this is going to be the bigger. So when I'm graphing this, and this is again, work we put in last semester is going to pay off, we have a y-intercept of -3, so boom, 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 and we're going to grow 2 each time. So I'm going to rise, +3. Then we're going to rise 2 each time, boom, run 1, rise 2, run 1, rise 2, run 1. So now when we go to put our line in, I'm going to try my best to get this out right. That's pretty close, not bad. Now let's go ahead and get our x-1 graphed. So we're going to start at -1 this time, because that's what the y-intercept is. And we're going to go up 1, over 1, up 1, over 1, up 1, over 1, up 1, over 1. And then connect it with a line. And I'll use green, because I don't have a blue line. I don't feel like make one right now. Okay. So now comes the interpretation part. Like, where am I looking for the red line to be bigger than the blue line? Well, the table has its own rules, but those are just numbers. Which of the two numbers is bigger? On a graph, it's all visual, so we know where they're the same. They're going to be the same right here. But on the left-hand side of the same, on the right-hand side of the same, which one's bigger? What does it mean to be bigger on a graph? Well, this is all about which line's on top. Lines on top, it's bigger. I mean, it has a bigger value. So clearly, path to the right side of this equal point is where this red is larger than this blue. So how do I interpret that to an answer? Well, what number are they the same? And then I want that, oops. Okay, so they're going to be the same right here, -4. And then I want all numbers to the right of it. Now, if this looks familiar to the shading we've done before, it should. We can't use -4 because that's where they're the same, and I can't have that. But I want any number that's bigger than it. So we're still looking at x is bigger than -4, which if you look, that's what we got over here. So it doesn't really matter how you solve it. It's how you see it. Do you prefer the table? Do you prefer the graph? When you come back on Monday or tomorrow, we're going to actually talk a little bit more algebraically how to solve it. Again, I'm going to add something to the mix if you don't like the, whoa, what's going on here? Okay, don't know what that was all about, but hey, we're over it. So let's get to the next problem. Okay, so consider this inequality 2x is bigger than 5x. Those three values you can substitute for x to make the inequality statement true. Well, let's figure out what this inequality statement even means. We have this 2x we're comparing to the 5x, and you have the sign in the middle. So which of the two sides is bigger? I'll wait. Larger. Okay, so a ton of likely candidates would just be like 1, 2, 3, 4, 5. But those are not going to work, and those are not going to work for an obvious reason. Because 1 times 2 is 2, 1 times 5 is 5. And then we got to get smaller, we got to get more dramatic. 0 won't work either, obviously, because 0 is still going to be the same as 0. I want to be smaller than the other. So we could approach this a couple different ways. Here's how I'm going to approach it. Instead of just kind of guessing in the dark, I'm going to make a graph. That's what I was taught to do. It's a visual representation of what my answers are. So that's what I'm going to do. So here we have 2x, which should be a reasonably steep line going through the origin. And then I'm going to graph now 5x, which should be steeper, but since they're both plus 0, it'll still go through the origin. So this will be like our 5x. Okay. Well, where is the red line above the blue line? Well, it certainly isn't over here. That's bad. This is crazy. But it is going to be bigger over here. So this is where I'm looking, in this region right here. So what x values exist right there? Well, if that's 0, what are all these numbers? -1, -2, -3. So what this is telling me is that just any negative number should work. So x equals -1, x equals -2, x equals -3 should all be good. Now we could check those. Okay. 2 times -1 is greater than 5 times -1. -2 is bigger than -5. True. Okay, and certainly anything else should work. Now the graph is really where our work is confirmed. Okay, so there's any three values you can substitute for x to make the statement false. Well, if all these negative numbers work, then positive numbers should work to make it false. Okay. And again, we can check it. So we have 2x is bigger than 5x, and go in and substitute one of our numbers here. 2 times 100 is bigger than 5 times 100. Well, not in this world. 200 is not bigger than 500. This is false, but that's what the question was asking for, so we're good to go. Okay, no, that looks like it. Okay, so guys, I'm glad you guys watched it. Sorry for how late it took us to get it up to the Edmodo, so you guys can watch it. If this is helping you, spread the word. Get other people to watch it too. I've talked to several teachers in the building, and they seem pretty cool with you guys watching these videos while you're in their Eagle Hour and stuff. And I imagine as long as you can prove to them that you're doing it responsibly, they're going to let you. So even if you can't watch at home, think about watching at school during the day. We'll start getting these videos up faster. Like I said, we just got to kind of work out our system. So thank you guys so much for watching. If you have any suggestions, have other questions, please don't feel hesitant to post them. We're going to be looking for them. So you guys have a great rest of your weekend. We'll see you tomorrow.